All right, now we're talking about expansion work, and expansion work is work arising from a change in volume. And in general, we have that dW, which is an infinitesimal representation of work. So we could say that work is just W, but if we say the infinitesimal of work, we can say dW, okay? So we can say that this quantity dW is equal to minus F dz, and dz is our infinitesimal for distance, and we can just say distance is z. We could have also alternatively said like x or y. We're just writing z here. And F is of course force. So we're saying consider a piston with area A. If the external pressure is P with the subscript EX for P external, the force on the outer face of the piston, so the piston facing the external air, so it's the face of the piston that isn't facing the inside of the piston, obviously the outer face. Then we say that the force is F is equal to PEX multiplied by A, the area of the piston or of the face of the piston, and we can say that because P external, the pressure external, is equal to force over area. And when the system expands through a distance dz, remember our infinitesimal, against PEX, we can write that dW is equal to minus PEX multiplied by the area A times this infinitesimal for distance dz. And if you combine the terms area and the infinitesimal for distance dz, then we get the infinitesimal for volume, or dv. So we can alternatively write that dw is equal to minus PEX dV. And then we can integrate that for an expression for work. So we're no longer going to be writing dW, we're going to be writing W, which is work, and it's not an infinitesimal. We're writing W is equal to, and then we have an integral with the lower bound VI and the upper bound VF, which stands for volume initial and volume final. And then we're integrating over PEX, so the external pressure, dV. And we have that when the gas inside the piston expands, it's going to move the piston a distance dz. And that movement is going to do work on the surroundings. All right, so conversely for free expansion, and in free expansion, we have expansion against zero opposing force. So in the other case, we had an external pressure. There's no external pressure here. This is an expansion into a vacuum, and we have that requires no work. So the PEX is going to be set equal to 0, and same with W for work. And then for expansion against constant pressure, we have W is equal to negative PEX multiplied by the change in volume. So you measure the initial volume and you measure the final volume, and that gives you your delta V. And for reversible expansion work, we know from the zeroth law that a system at equilibrium tends to undergo reversible change. And the reversible change here, when we're thinking about expansion work, is that we're going to consider the same setup as before with the piston, but we're going to consider that the gas pressure inside the piston is the same as the external gas pressure. And we're saying that this system is in mechanical equilibrium. So if we have an infinitesimal change in pressure on one side or the other, then the equilibrium will be restored. And that this change is reversible. So the change in pressure is reversible. But if we have a large change in pressure or a large difference in pressure between the external pressure and the pressure inside the piston, then it's not in mechanical equilibrium and the change is irreversible. And again, here we're describing the work in this situation as W is equal to the integral from VI to VF, and then we have we've got a negative sign on the outside of the integral, and then after the integral sign we have P dV.